lesson is from Chapter 5, Lesson 2, Proportions. Your essential question, how can proportions help you to decide when things are fair? The meaning of the word proportional. When you work toward a goal, your success is usually proportional to the amount of work you put in. An equation stating that two ratios are equal is a proportion. So we have two vocabulary terms here to start off with. The first one being proportion, which is an equation stating that two ratios are equivalent. Remember the word equivalent? You can kind of see the word equal in there. Equivalent means equal. And two ratios that form a proportion are what we call proportional. So we learned in the first lesson of Chapter 5 that a ratio is simply another way of stating a fraction. So the numbers 2 to 3 is equal to 4 to 6 is proportional. And we're going to prove to you why they are proportional in example 1. So that is an example of a proportion. 2 to 3 is equal to 4 to 6, or 2 to 3. 2 is to 3 as 4 is to 6 is another way of saying that. So if we look at example 1, we're going to show you how to determine whether these two ratios are proportional. So we're looking at 6 to 4 and 8 to 12. So there's two ways of going about doing this. One way, 6 to 4 is equal to 8 to 12, is to find their cross products, meaning multiply diagonally. And if you end up with the same answer diagonally, then those two ratios are a proportion. So 6 times 12 is 72. And 4 times 8 is 32. Since 72 does not equal, I have a line through my equal sign, meaning not equal to 32, then tell whether 6 to 4 and 8 to 12 form a proportion. This would be a no. Right? They are not proportional because their cross products are not the same. The other way to do it would be to simplify each of the ratios. So 6 to 4, what can go into 6 and 4 evenly? They are both divisible by 2. We divide by 2 to simplify. 6 divided by 2 is 3, and 4 divided by 2 is 2. So we have 3 to 2. And then do the same thing for 8 to 12. We're going to simplify that one. What can go into 8 and 12 evenly? They are both divisible by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So I'm looking at 3 over 2 and 2 over 3. Are they equal? No, they are not equal to each other. So since they're not the same, again, no, these are not proportional. So we can go back up to the example and just double check, make sure, are these proportional? Sure they are. What's 3 times 4? That's 12. What's 2 times 6? That's also 12. So since we have 12 equals 12, that's yes, it is a proportion. Or the other way of doing it, 2/3 is already simplified. Nothing can go into 2 and 3. But we can simplify 4 to 6. They, again, are both divisible by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So you've got 2/3 and 2/3. So, yes, they are equal to each other. Therefore, they are proportional. All right, so the two ways to determine whether ratios form a proportion: finding their cross products. If they're the same, yes, it's proportional. If they're not the same, no, it is not a proportion. And the second way of doing it would be to simplify the fractions that you're given. If they do not equal the same fraction simplified, then they again are not a proportion. Moving on to example 2, determine whether two quantities are proportional. So tell whether x and y are proportional. So looking at this table, in order for these to be proportional, you have to determine, is x over y the same for all items in the table? So let's determine that. So x over y. The first one, I've got x is 1/2 and y is 3. This would be an example of a complex fraction. So this is really looking at 1/2 divided by 3. 1/2 divide it by 3. Remember, we don't divide fractions. We do keep, change, flip. So that would be 1/2 times 1/3. 1 times 1 is 1, and 2 times 3 is 6. So that one gave me 1/6. The second x over y is simply 1/6. There's nothing to do there. We can see so far we have two of the same. The third one would be 3 over 2 is my y, or sorry, is my x, and 9 is my y. So we've got 3 over 2 divided by 9, which becomes 3 over 2 times 1/9, the reciprocal of 9. I can cancel here because 3 and 9 are both divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Multiplying across now, 1 times 1 is 1, 2 times 3 is 6. So far I've got 1/6 for 3 of them. I'm going to check my last one. 2 over 12. That's a nice regular fraction. It's not complex like these two were that we had to use the division. So here we can just simply simplify it. What can go into 2 and 12 evenly? Both are divisible by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So you can see, oops, I went to circle the whole thing, 1 over 6, 1 over 6, 1 over 6, and 1 over 6. Since all of the x over y were the same, this would be a yes, that it is proportional. All right, that one has a proportional relationship. So I want you to pause the video now and see if you can do the 5 on your own problems. The first 4, you're just telling whether or not the two ratios are a proportion. So you can go either way there by doing your cross products to see if they're the same, or by simplifying your fractions, whichever one you feel more comfortable with. And in number 5, you're going to tell whether x and y are proportional, just like we did in example 2. So check, is x over y the same for all of them? Pause the video now, do your work, and then come back and check your answers. In number 1, I'm looking at my cross products. 2 times 5 is 10. 1 times 10 is 10. Since they are equal to each other, this would be a yes. If you simplified them, 1/2 is already simplified. 5 over 10 can be simplified to 1/2 by dividing both the top and bottom by 5. So again, you would get 1/2 equals 1/2, which is also true, making it proportional. In number 2, you're looking at your cross products. 6 times 18 gives me 108, and 4 times 24 gives me 96. These are not equal to each other, so this would be a no. I find the cross products to be a little bit easier. If you did it by simplifying them, you should have gotten 2 different answers when you simplified, and that would again tell you no. In number 3, your cross products, 3 times 5 is 15, 10 times 6 is 60. These are not equal to each other, so another no. And in the last one, 20 times 15 would be 300. 25 times 12 is also 300. Since they are equal to each other, that one would be a yes. And in number 5, birdhouse is built and nails used. We're going to check to make sure all the x over y's are the same. The first one, 1 over 12. The second one, 2 over 24. That one can be simplified. They are both divisible by 2. 2 divided by 2 is 1, and 24 divided by 2 is 12. So we can see 2 of them being 1 over 12. The next one, 4 over 48, we're going to simplify. Both 4 and 48 are divisible by 4. 4 divided by 4 is 1. 48 divided by 4 is 12. And the last one, 6 over 72, we're going to simplify that one by dividing both top and bottom by 6. 6 divided by 6 is 1, and 72 divided by 6 is 12. So again, we can see that every single x over y gave me 1 over 12, which makes this yes, it is a proportional relationship. Moving on to our next key idea, which is cross products. We kind of were already using the cross products to determine whether they were a proportional relationship. I showed you both ways from the get-go. So when I talk about you doing your cross multiplication, that's just your cross products. It's taking B and multiplying by C, and taking A and multiplying by D. and they are what we call our cross products. They're across from each other, they're products because you're actually multiplying. So you can see in your example, you did 3 times 4 here, and 2 times 6. This gives me 12, and this also gives me 12, so this would be yes to a proportional relationship. And this is algebraically just using letters. Makes more sense when you actually see it number-wise. So we actually already did this. We'll just do a couple more examples. Identifying a proportional relationship. All right, in example 3, we're going to identify the proportional relationship. I'm going to show you 2 methods again. We're going to compare unit rates, and we're also going to do cross products. You swim your first lap in 2 4/10 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So in the first one, I can see that I'm doing 2 4/10 minutes, and I'm getting done 4 laps. So I set it up as minutes over laps. In the second one, 16 laps in 12 minutes. If I did minutes over laps up top, I want to do minutes over lap here as well. That's 12 minutes, and I'm getting done 16 laps. Now, if we remember, a unit rate, comparing unit rates, has a denominator of 1. So to get it to have a denominator of 1, we can set up a proportion equal to x over 1, or by simply just dividing. 2 4/10 divided by 4, if you were to plug that into your calculator, it equals 6/10. So that 6/10 is 6/10 minute per lap. So every lap I do, it's taking me 6/10 of a minute. Down here, if I do 12 divided by 16, that equals 7/500 minutes per lap. Were their unit rates the same? No. These are not equal to each other. Therefore, this is not a proportion. So one way is to change to unit rates and compare. The second way, may seem a little bit easier, is to set up a proportion to find your cross product. So we're starting with 2 4/10 minutes, 4 laps. Is that equal to 12 minutes and 16 laps? So please notice that since I did minutes over laps, I must have minutes over laps. I can't switch them up. Now I'm going to check my cross products, multiplying across. 16 times 2 4/10 gives me 38 4/10. And 4 times 12 gives me 48. And again, I can see that they are not equal to each other. So that would be no for it being proportional. So it's just 2 other ways of doing it. Unit rates, having a denominator of 1, minutes per 1 lap, or finding your cross products just like we did in the other examples. So see if you can set up and solve the on your own problem, and try it both ways. Find your unit rate and also do your cross products. Do both methods, please. Then come back and check your answer when you're done. You read the first 20 pages of a book in 25 minutes. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? So pages to time, I've got 20 pages, right, PGS for pages, in 25 minutes. I'm going to make that into a unit rate. I'll do that by dividing. 20 divided by 25 is equal to 8/10 pages for each minute per minute. And the second one, 36 pages in 45 minutes, pages on top, 36 pages to 45 minutes. A ratio, we're going to divide it to make it a unit rate. 36 divided by 45 is equal to 8/10, and that again would be pages per minute. Notice that they both have the same unit rate. They're equal to each other, therefore this would be a yes for a proportional relationship. The other way you could have did it was by using your cross product. So we'll start with 20 pages over 20 minutes again. Sorry, 25 minutes. 20 pages is to 25 minutes as 36 pages is to 45 minutes. And we'll look at our diagonals here. 20 times 45 gives me 900. 25 times 36 also gives me 900. As soon as you see your cross products being the same, again, that is a yes for a proportional relationship. All right, so that's all we have for proportions.